So in this video, we're going to see how to build various time forecasting models and see which one to choose on the basis of having the smallest mean square errors. This is the 85% of the original data set by date, price of oil, which month you're in, the 12-month dummies, and the 4 lag prices. We're going to run a multiple regression, auto regression, and multiple / auto regression, 3 different models, and see how well they do. To stress test each of these, I have used the same holdout sample. So these are 15% representation chosen at random. We're going to ask each model to go back in time and see what price they would predict. So Excel will ultimately stick in the predicted price of oil over here. This is your prediction data set technique that you used early in Milk and Money, for example. And then what I have here is the actual price of oil in that month, minus here's the predicted price of oil according to this model, and then the difference of course would be error squared gives you forecast errors, summed up gives you mean squared errors. So let's see how you run these regressions. The first regression is of a multiple regression. So I'm going to now select all variables, choose price of oil as the dependent variable, unselect money, month. There are 12 months, unselect one of them, January, go down here. Since I'm not doing an auto regression, uncheck these lagged variables right here, and I'm going to see how it actually does in the holdout sample. Choose the holdout sample for multiple regressions. Ignore the messages. And now we have the multiple regression. It tells us that date is significant. Each month that passes by raises the price of oil by $0.0003 per gallon. The dummy variables, although they are insignificant, 95% confidence, tell us the following. For example, in February, all else equal, the price of oil will be $0.06 per gallon higher than the month of January. How did this do in the holdout sample? Excel has stuck in the predicted price of oil along with the confidence intervals for each observation, and I can now predict the mean square error to be 7.46. Let's do the same thing for auto regressions. Go back here, deselect all, and now I'm going to regress the price of oil on the 4 lagged prices. See how well it does in the holdout sample for auto regressions, and now ignore messages. If I now go over here, you can see that the price of oil 1, 2, 3 months ago is significant. And then what we have here is the holdout sample. You will notice that the mean square error is 1.97, far better than the first model. Finally, we have a regression, and now we run the full model. Select all. I'm going to choose oil prices dependent, drop month, drop one of the dummies to see how well it does in the holdout sample of multiple and auto regressions. Press OK. And now we see how it does. And now you will notice that date continues to be significant. That tells you the effect on the price of oil with each passing month. The dummy variables are, from what I can tell right now, are almost insignificant except for the month of October, which is kind of interesting. And the lag prices are, of course, over here. Prior 3 months are significant. How did this model do in the holdout sample? Well, it stuck the predicted prices over here, 95% confidence interval, and this has a mean square of 2.01. So this one is 2.01. Auto regression had 1.97, whereas the multiple regression had 7.46. According to this model, the auto regression one was the best.